What I'm going to talk about, I'll do a few minutes on just giving an overview of Azure ML. Just for context, how many of you have gone to sessions this week on Azure ML? Many, most, good. So I'll just sort of zip through it to get everyone on the same page, and then we'll talk about common patterns that we see customers use for solving business problems using machine learning. I have a few examples of customers sort of using ML and want to share that with you and how they've broken it down. And then we'll talk about the people, process, and platform that and lessons in all of those that help machine learning projects become successful. So Azure Machine Learning is part of the Azure AI portfolio of solutions. And machine learning is clearly one of the solution areas. We have AI apps and agents. These are pre-built models and the bot framework that help you build sort of a natural AI-enabled applications and bots. And then there's knowledge mining, which is the ability to sort of look at, use AI to understand the semantic meaning inside documents and get value out of them. There are a lot of sessions on each one of those, so I'm going to talk about machine learning today. So machine learning, we have four major investment principles or investment areas. The first one is productive for all skill levels. We think it's super important as enterprises go on the ML journey that they have the right tools and the right infrastructure to sort of build ML and become successful. Not every company has a plethora of PhDs who have done R or Python and able to sort of build models using code. And so we have a code-first experience in Azure Machine Learning. We also have a no-code experience using a visual drag-and-drop experience. And then we have a wizard experience based on automated machine learning that allows someone who deeply understands the business and understands the data to build models without deeply understanding machine learning. So we have tools for all three skill levels and preferences, and all of that is built on a platform that allows you to manage all of your assets, your machine learning assets, such that you can put those models into production. And so the next one is around how to deliver industry-leading ML operations. And this is our idea of making sure that the models you build by your data scientists can be operationalized and run in production with the rest of your business processes and your applications. The third super important principle that we work on is open and interoperable. This is important because so much of AI innovation is happening in the open. And so as a design principle, we make sure that anything that's available in the open, as a paper that's been written and a data scientist wants to use, they're able to easily get all that of that information and the code into Azure Machine Learning to do that experimentation. We also support the full R and Python ecosystem, which is basically covers probably 95% of all machine learning at this point. And when we have, as Microsoft, when we have innovations to share, we share that all the algorithmic innovation in open as well. Things like our contributions to PyTorch, Horowad, Kubeflow, Kubernetes. So we work making sure that all of the work that we do in AI sort of shows up in the open and then is usable inside Azure Machine Learning. And the last one is trusted. We think of trust at three layers. There is the trusted platform, and that's Azure. So in addition to all of the trust that you get from security, privacy, region availability, compliance, we also think about trust of the process, which is the process that made your machine learning model work. How do we make sure that we capture all of that? So how do we keep track of data, the lineage, the versions, who gets to approve? So all of that stuff is tracked as well. And then finally, it's a new area for us, is trusted models, which is the models you're building, are they any good? Are they fair? Do they have bias? Can you explain what the model is doing? So this is a new area for a lot of companies, and they're all very interested. And so we have a bunch of tools that allow you to sort of start working through and understanding your models. So in a nutshell, Azure Machine Learning sort of has three pieces of news from this Ignite week. So we're introducing an Enterprise Edition, which is a enterprise-ready set of capabilities that include the visual designer, automated machine learning UI, and a bunch of high-end enterprise readiness features. We have a single data science experience, the new studio that brings together all of the tools and the assets that you need for a data scientist to succeed. And then we also are announcing our support so that you can capture the rest of the data science ecosystem that we did not cover with Python. There's a blog post with all the gory details that we have released. We have literally hundreds of features that we have sort of announced. So take a look at that to understand the full breadth of the capabilities. So just to just finish up, at a high level, Azure Machine Learning is in 4 layers, 5 layers. We have the experience layer, which is what we talked about. There's an SDK, notebooks, drag and drop, and wizard. We have an MLOps governance layer that talks about reproducible, automatable, integration with GitHub, the CLI, the REST layer, allows everything to be automated. Then we have 4 major sort of ML services underneath it. There's the data sets. How do you project data into a machine learning workspace so that a data scientist has the flexibility to do data science without sort of while being compliant with all the governance policies of the company. Training, which is the inner loop and the outer loop for doing training. Model registry, our single source of truth for having your models and versioning them. And then inferencing, which is putting these models into production, both in online, in the cloud, and the IoT as well as batch. And then this works on an abstraction for cloud compute as well as IoT edge. And so we integrate with both of those systems. And then we take advantage of all the best AI hardware that's available in the cloud and in the IoT device. So this is not an architecture. I'm always told it's a marketecture. But it sort of gives you a good idea of the layers and of the core capabilities of the product. All right, with that, I'm going to shift from the overview to patterns. So I read this article by Cognitica. I don't know how to pronounce their name, but they're down here. They've done a really good job analyzing just hundreds and hundreds of customers and the use cases for ML. And it turns out almost 95% of the time, you can put them into one of these 7 patterns. And it's really, really helpful. So when you start looking at your business problem through this lens, you can start seeing how to put machine learning into practice for your business. So let me take a couple of examples. Hyper-personalization. This is the ability for using machine learning for you to work really deeply understand your customer. So if you're doing ads like we do, you can do ad targeting. You really understand the customer behavior. You understand what ads to project to them. You could be ASOS, which is showing the next piece of clothing that you want to have, and and how do you sort of recommend. It could be personalizer, which is like personalizing your experience for your dashboard, right? And so in each one of these cases, what you're trying to do is using the data and the user behavior to better match the customer where they are. And so you're really sort of giving a very, very high quality experience for the customer, and therefore sort of increasing your lift in your business. Another common example that we often talk about is predictive analytics. And so this is when you're using data from the past to predict the future, whether it could be forecasting, sales, predictive maintenance. There's a ton of problems that you can sort of just look at what you're already analyzing and saying, how can I play it forward? How can I make sure I look at it in the future? And then another example is sort of patterns and anomalies. And this one you're saying, look, I have some knowledge of how the past is working, and if I just look at any data point in the current, I can say it's anomalous. So if you're looking at your sales and you find something just suddenly drop off, you can say, oh, look, I want to get alerted at it. It could be something from a signal from an IoT device, and if something goes wrong, you're able to detect it very quickly. So these are common patterns. So while I talk about in the abstract, I'm going to give a few examples now from customers who have looked at their business problems through this lens, and I want to sort of deep dive into a few of them. All right, so Schneider Electric is a company that is building pumps and for oil rigs. And so their problem was, hey, look, I want to make sure that if it breaks, often these rigs are in all kinds of places, it's really hard to fix, and it's a very high downtime for their customers. And so they want to do predictive maintenance on it. And so what they've done is sort of broken down the problem into 4 major parts. So they figured out what data do they need. So they're ingesting the data from the pump itself. So displacement and load measurements, there are sensors that are sitting on the pump and the rod that's going up and down. And so they stream all this data to Azure, and then they train their model with that time series data. Now, what they did in this particular case is they used automation machine learning. And and what automation machine learning found is that it's an ensemble model of a support vector machine and a logistic regression. And so they pulled that together. Sorry, it's a random forest, sorry. So they pulled that together, and that's their sort of the core training model. Then they deployed that through our IoT Edge integration to an IoT gateway. So what they do now is they have a custom application, which is their Schneider application that's run on site, that is calling this edge device that with a web service call. And it is giving basically every rotation of the motor that prediction is being created that says, is it likely to break or not? And this gives the operator really great insight into where all of their devices are. One of the things you'll see in this pattern is that it's a complicated problem. But once you start breaking them down into individual pieces, it starts becoming a little bit more clear. The other thing that we've noticed is that we often talk about ML sort of with training and inferencing. But there's a lot to be said about how do we consume, which is you want to make sure that the ML prediction is consumed in the most natural way in your existing business process and your existing business applications. So as you think about your projects for putting machine learning in, we found this to be a very good way to sort of break the problem down. So I'll take another example, totally different area, say not different industry, but again, you'll start seeing what's being common about them. So this is Newcrest Mining. Now they're a mining company in Australia, and they have these giant open pit mines. And so the problem they had was to figure out, as the trucks are coming from the bottom of the mine, they're coming up, and these are these huge trucks with feet-high tires. They're coming up, and they have 3 crushers at the top level. And sometimes these crushers jam up because there might be metal in them, there might be a stone or material that is too big, or it's just or it's getting jammed itself. There's like something going wrong in there. And so what they have done in order to predict, what they want to do is to say, I'm going to predict that this crusher is going to be jammed, and it's going to slow my processing of my material. And so they want to reroute all the trucks that are already coming up the mine, right? And so they basically reroute them to a new place, to one of the other crushers. That way they can keep their time to move within SLA. So if you look at that problem, it's kind of cool. And they have some very simple thing around the camera is placed in every crusher that just really looks at images that says how much volume is going through the system. It detects metal, it detects size of the object as it does object detection, and then it starts triggering an alert. They use sort of DNN models for doing this training, and they also, what they've done is, as the mine mix changes, for instance, if you go deeper down, the color of the material changes, they do a retraining because they find that the images have sort of drifted from the training data. Then they do inferencing, and here the inferencing is actually in the cloud. And so there's an endpoint in the cloud, and we have the consumption from, again, their application that is built and the process that they have. So this has been very successful for them in terms of understanding, to improve the flow of their material, and is a good example of machine learning working. So next, I want to sort of give one more example, and to give that example, I want to invite Srilekha Varanasi from KPMG. She's a senior manager there, and we're going to talk about their use case for recommendations. Srilekha, welcome, thank you. Can you describe what you do?
I'm a solution architect at KPMG, and I currently drive the cloud strategy on KPMG tax practice for data science and data engineering.
Excellent. And tell us how you've been using ML in the tax area.
So KPMG deals with a lot of corporate clients, and tax touches every aspect of their business transactions. So there's a lot of data, and we have these highly trained tax professionals who understand tax law and have deep expertise in going through the tax regulations and applying it to all these transactions. But most of the time, they find themselves actually focusing more on identifying the hidden data in these transactions and applying and it leaves them with little time to actually give the value-added tax services to our clients. So our group comes in and kind of expedites this by adding technology and moving this faster in that aspect.
Awesome. So I know that you're a very, very demanding customer of Azure ML, and so you've given us a lot of requirements. So I know you use Azure ML. Can you tell us how you use Azure ML and why you use it?
So one of my favorite features of Azure ML is Azure ML Compute. And that allows our data scientists to kind of have these pre-configured ML compute deployed in our private network. And as data scientists work on these data loads, a lot of times they look at the data and they say, okay, I can probably use this particular algorithm and probably a CPU cluster is good enough. But as new data comes in and they see a need to change to a different type of algorithm, say they want to do deep learning, and they suddenly realize that I need a GPU, if it were to be on-prem, we typically go through a change management process, create a GPU cluster, and then work through that. But over here, because we already have it pre-configured and it doesn't cost us anything, we're just switching it without actually changing our much on the configuration or going through a change management process. That is huge advancement for us. The ability to be able to run and submit experiments without having to be explicitly logged into the compute is great. Cost management, because nothing costs if we have those pre-configured out there. And also the flexibility to use any algorithm, Python algorithm, scikit-learn, or any other deep learning algorithm without having somebody to dictate what to use is great.
Wow, using all parts of the Azure Machine Learning platform.
Pretty much.
But I've heard from a lot of customers that the platform is one part of enabling ML, but there are a lot of other problems that happen too, or other issues that we have to think through. Can you share us your journey on how that happened?
So when we embarked on data engineering and data science journey, it was definitely not the norm where IT implementers would actually work with the production data. It was definitely two different silos. But as technology started advancing and we started working with our digital security group and tax risk management group and kind of built that awareness, and the lines started diminishing. We now treat it as a single group with varied skill set, both business and IT working together and working to a single goal to solve and move forward. So yeah, that was definitely a journey. And we also had a lot of huge support from our leadership and moving forward there.
That's great to hear. Well, thank you so much for being a great customer of ours and for pushing us to build a better platform.
Thank you for having me here.
Thank you. All right. As she mentioned, there are a lot of issues that are not in the platform, and I think that's what we've seen time and time again in our deployments, is that there are other concerns that you have to think through, and we talk about people and processes as two big items that we want to talk through. So here are some sort of thoughts that we've had on sort of how to recognize the issues and sort of ways in which you might want to think about it going forward. So first, there are multiple personas involved. I think one of the analyst firms talks about this as a data science is a team sport. You saw Sri talk about it as well, as working as one V team. And so we talk about data engineering as the sort of practice that has developed in the last 5 years to really build your data lake, to feed your BI engines and your analytic engines. You've introduced data scientists, and you've always had software engineers, but also now there's this idea of like an ML engineer who is aware of the concerns of doing ML. For instance, taking Python code to production, or converting a deep learning model and optimizing it for your hardware. So we have these three roles, and then there's IT in the center that's really orchestrating and enabling all of this work. And so we've noticed some interesting patterns about sort of these personas and how, while they're all really well-intentioned, sometimes they might be in conflict. So first is data engineers. And so they're focused really on developing the source of truth, the single source of truth. That's what they do. They curate the data set. They add business logic. They work closely with the business to clean data, to remove dirty data, et cetera. And they're also all the time concerned about reliability. They're running 24/7 pipelines that need to be always correct so that the BI system downstream can consume it. This is great. They have developed a set of practices. Now you have the data scientists who are looking at the data. They're looking at it from a very different perspective. They want all the data. They want raw data. They want dirty data because they want to look at everything, because they're always looking for some signal, right? Anything that will move the model and move the metric. And so they have less concerns about the 100% accuracy. In fact, in machine learning, 100% accuracy is not that interesting. Some noise actually helps make a better model. And the one they're most concerned about is agility. And you again heard Sri talk about how data scientists are really happy that they can just sort of keep iterating. When they had a GPU-enabled algorithm, they could just have it, because otherwise the speed goes down. Because their core work is experimentation. They keep trying it. And so I mark these things in green because they all seem like really good things, but they sometimes can be in conflict. Like you can't be both reliable and agile without some thought process around it. And then you have the ML engineer, who has a totally different set of concerns. They are interested in putting the model into production in a live system. As we talked in Newcrest, we talked about how the engineer is putting model that's in an IoT device that's running on site. So that is, they are really careful about what they ship. And so they actually take the model, they modify it, they optimize it, they modify the application, and then they're sort of super concerned about performance and operational metrics. So now you have another persona that is like looking at a different set of problems. And then finally you have IT. You're supposed to enable all of this work. You're supposed to trade off between speed and safety and meet all these requirements. And so the sort of lesson we've learned from this is really, you can't totally be successful unless you realize that all these folks have really good reasons to want what they want, because that's how you succeed in the profession. But they're sometimes in conflict. And so you have to start thinking through, how are you going to negotiate and how are you going to engage these teams? I've had, probably in the last 6 months, 100 customers I've met one-on-one, and they often talk about, the data engineer would say, like, the data scientists are crazy. They want all the raw data or all the production data. How many of you have heard that? Some? The reverse is the data scientists say, the data engineers are really slow, and they're not giving me everything I need, because that's why I want to get back to raw, right? And so the thing is, they are trying to do their jobs. They're not crazy or they're not slow. They just have different constraints that they're working towards. And so one of the things we always talk about, we ask is, and places where we've seen it successful, is IT really enabling that conversation and sort of creating a bunch of sort of rules and governance around how we sort of make this journey happen. So it's a critically important activity you have to do to make that move forward. So I think many times we've heard the data scientist has built their model and shown uplift. And then only 80% or 70%, 60 or 70% of those models never go into production, because they run into trouble with the next 2 or 3 parts of the system. So it's really important to understand that the people and organizations, often these are also encapsulated as organizations. So the organizational element is also an issue. So what we always say is, be aware of this, and you have to start tackling them head on. Otherwise, you're not going to actually make this thing successful. So let me get a drink of water here. All right, the next is the process. So you have these 3 folks. They have different constraints and different aspirations and different goals that they were trying to optimize. And you recognize that they have different needs. So let's go through what they're doing. So first, we'll talk to the data engineer. So they are looking at the data lake. They're getting the data in through ingestion. They're running these pipelines to create these curated data sets and clean data sets. They're putting them in a catalog. Awesome. Then you probably have engineers, app devs, who are already working on building great applications. They are adopting DevOps. They're building, they're creating their release pipelines. They're building their application, validating it, and doing continuous CI and CD. That's another part of your organization. That's great. Then you have the data scientists. They're also doing their own thing. And so they're, often I hear stories about data scientists are doing their experimentation, which is their inner loop, and they want the data. They get some data into their laptop, some small data set, and they're migrating it. They're showing their manager how great the solution is. And then the next step is, I want production data. I want all the data, because otherwise I can't build the model. And then they run into troubles with the rest of the system. So now what do you do? So what we say is, you have to think through each one of these lines that are going to interconnect them. You have to think about them as a organizational process and policies. So first, you got to say, Mr. Data Scientist, let's work with data engineering to figure out what data you need and get the data that you need in the right way. The right way may be giving raw data, it may be giving production data, but the idea is that it is agreed upon between the teams to say, how are you going to get the data there? What are the policies and governance for RBAC? Who gets to see the data? Who gets to use the data? Do they get to understand it? So you have to, so like that little line is actually a lot of work, because you're going to run afoul of a number of things. The data sets you might be making for BI may be completely not right for AI. And we've had that problem in spades at Microsoft. We built great data sets for Office, for BI, and then when they wanted to do a bunch of AI work, we just didn't have the signal, because we had cleaned all that stuff out because the BI user just didn't need it. And we thought it was all noise, and we could remove that out. And so we had to start having a new conversation about what is the ML data set that is different than the BI data set. So you got to have that conversation. You got to do some new work to make sure you get the data in. You got to help the data scientists start using GitHub or something else to sort of say, look, all the code you have, you can't leave in your laptop. It's got to be Source Depot. Source Depot is our internal system. You got to use something like GitHub, and you got to have versions. You got to make sure everything, all the code is available and reproducible. Then you go into the next step, which is once you build the model, you can't hand over the pickle file on a flash drive. That has happened before, or some equivalent of that. And so you got to put all your models in a place that is a company asset, that is versioned, has metadata, right? And so you got to get that into the model registry. So again, some of these changes will be difficult for data scientists because they're going to say, hey, look, it's really slow for me to do all this extra work. And so you have to sort of start thinking through the conversation that says, look, if you want to put them into production, there are some set of tools and practices you have to do to make sure your model goes into production. Then you now invoke the ML engineer persona, which is a software engineer or your IT, to start thinking about what are you going to do with ML. And so you have to create release processes. So when a model comes up and you get a new version of it, you need to be able to say, look, how am I going to package the model? How am I going to optimize the model? How am I going to validate the model? Approve, deploy the model. So all of these now have to be done for models as opposed to just code. And there's a bunch of skill involved, and often the data scientists will be very much participating in this exercise because they understand the intent of the model, while the ML engineer will be spending the time sort of doing the operational work and making the technical work to make sure that this is optimized for the endpoint. Sometimes you'll deploy that as a real-time endpoint. Sometimes you'll deploy it as a batch. Sometimes you might take it as a container and put it inside your application. Sometimes you might just take the resultant code and just compile it into your other application. So that's the work that the ML engineer will be doing. Then you have to make sure that the model, as it's running, is collecting good data for both the operational part as well as the machine learning part. And so you have to collect metrics like performance, memory size, et cetera, for operations, but you also have to collect data like what data you're getting for predictions, what data you're getting as input, what is your error, all of those information. What's the feedback for that prediction? Was it a good prediction or a bad prediction? That comes from the application. You collect all that, put it back to the data lake, and now since you've talked to your data engineer, you're building the feedback loop. So you not only have the data for training, you also have the feedback loop from the model in production. And now suddenly you have this process, this golden process that says, I have the data going in, and I have training, I have the great production release management, and I get the feedback, and I'm good to go. Once you have this established, it takes a bunch of time, and each line is a conversation. Each line is a set of decisions you're going to have to make about policy, about governance, about who owns this, who does what. And so don't underestimate the work involved there. Now, we as Microsoft, we will provide you a lot of the technology platform, with the next slide, to enable each one of these things. But as a customer, you have to reason about a lot of these things with respect to your company's DNA, your values, and your organization, and your priorities. These don't happen automatically. And so our big sort of ask is, think through this as a human element as well. So just a quick show of hands, like how much of this rings true in your ML endeavor? Some? Okay, good. For others, is it true, or you just haven't run into it yet? Okay, maybe I asked the question badly. For how many of us you haven't run into it yet? Okay, mostly the rest of them. Okay, so I think this is what will happen. And so don't be surprised, and we'll try to make sure as Microsoft, we'll sort of take this information and sort of make it available as guides to help you through your journey. But the fact is, just having the technology or just having a data scientist is not enough. You have to sort of make sure the whole thing works. All right, the last part is relatively simple. So we'll just go through the same walkthrough. So there have been lots and lots of sessions so far on all the technical capabilities. I'm not going to go through each of the capabilities, but what I want to show is, as you think about machine learning, you want to think about all of Azure as your platform. I often find customers saying like, hey, look, you're not end-to-end. The platform is Azure not Azure Machine Learning itself, but for your entire machine learning journey, it is all of Azure. And so as I walk through these 4 dots and the 3 personalities, let's look at the list of products that are involved. So you're doing data engineering. You're looking at Azure Data Factory. You're doing your ingestion. You're looking at Azure Data Lake to store your data. You're looking at Synapse, the new announcement, as well as Databricks for doing your data engineering and your analytics. You're doing your cooking there. You're building these data sets. I should also include Azure Catalog, but I think that's going to be sort of part of the Synapse naming. So you have a whole bunch of assets to build your data platform, to build the data sets, and to fund data into machine learning. Then you have data scientists who are going to use things like Azure Machine Learning to get a sort of secure environment in which they can do their experimentation, work with GitHub to store your code and your models, use all the open source technology that's around for doing AI, so like TensorFlow, PyTorch, scikit-learn, basically the entire Python and R ecosystem. And then, as Sri mentioned, Azure Compute. You will use the hardware that's in Azure to make sure that you have the best capability at the lowest cost. And then you work with your whole app and infrastructure to deliver these applications. And so you're going to, I didn't include VS Code or Visual Studio, but basically you're going from all the way from app development, Azure DevOps to orchestrate that whole lifecycle. Again, GitHub as a key point for storing all these assets. Azure Kubernetes Service to build out and store to run your online cloud models. IoT Edge to deploy it to the edge. And so you have this entire ecosystem or set of products and capabilities that you're going to have to look at as you look at your reference architecture, as you look at your application. Azure Machine Learning as a whole has been built with this exact sort of set of roles and products in mind. So we have deep integration with Data Factory. We can use the information in Data Lake directly with our data sets. We are working closely with Synapse as they go from preview into GA. We have great integration with Databricks, whether it's two-way integration. So when you're in Databricks, you can use our Azure Machine Learning SDK. You can connect the MLflow API tracking server to Azure Machine Learning. That allows you to sort of keep track of all of your experiments and your entire lifecycle. You can also do it from Azure Machine Learning. If you're doing that and you want to sort of run a job in Azure Databricks, you can run it the other way too. We talked about Azure Machine Learning and GitHub. And then we also are now deeply integrated with Azure DevOps. So you can take an Azure DevOps project, point it to an Azure Machine Learning workspace, and all of the assets in there become first-class citizens. So when your code changes, when your data changes, when your models version, each one of those generates triggers that then can be used as a driver for that lifecycle. We also provide direct Azure Kubernetes service clusters. So we actually provision the cluster for you and run your model there. And then we can take our models and put them into IoT Edge. So this is sort of really the whole circle, so to speak, for Azure Machine for the lifecycle for ML. All right. So I'm going to come to the summary. So just in a nutshell, so we have patterns. Almost every business problem can be enhanced with machine learning. And I think I found this 7 patterns to be super helpful. It helps me understand it. It helps me very quickly say, oh, I have a forecasting problem or I have an anomaly problem. And so just as you have your conversation with your business owners, whether use this 7 or use something else, use a way to sort of think about how machine learning can help. I've had a lot of customers sort of say, hey, look, Microsoft, I have this big data lake. I have all this data. Can you help me do some AI? And the fact is, we can't. We don't know your business. We have no idea, right? And so I always defer and I say, I can't help you. What you should do is talk to your business owners, right? And talk to them and guide them through this process of saying, hey, look, machine learning can do all of these things. Like, where do you have problems that can get benefit of this? Use examples like the ones we did. Then the second problem is once you have this business problem, you have to break it down. And so you really want to break down the problem into smaller chunks. Otherwise, it just becomes an immense problem of all new things. And so each one of these problems around ingestion, you probably have already solved this problem. But the thing is, how do you connect it to the next step, which is your data science part? What tools do you use for data science? Then into production, where do you run your model? Do you run it as a notebook? Because that's how you probably were to show business value in the first place. But to production, you have to say, is it batch? Is it a batch inferencing system? Is it an online system? Is it an online system in the cloud? So those are decisions you got to make. And then you have to think through how to get the feedback loop. The next one is people. So successful machine learning will require culture change. I think everyone has heard this. I think we're trying to sort of show you what that culture change looks like. It means that the data scientists will have to learn over time to say, look, I have to be a little bit more formal about my work. I just can't sort of make a notebook and call it good and sort of show a cell that says, look at this uplift on this metric. It's great. And that my job is done. Their job is not done. They have to make it reproducible. They got to put it in a pipeline. They got to talk to data science, to data engineering, and to ML engineering. Data engineers, on the other hand, have to change their mind too. They can't say, I can't give you all that thing. You only have to use accurate data. It's a different problem. It requires different data. So you need to understand how to maybe build a second pipeline or a derivative pipeline for helping ML. So the culture change has to be driven through business, through IT. IT is well placed to do that, but you have to sort of have this as a team sport. And then I sort of mentioned this again. Different personas have different needs, and they're all good needs. They're all positive words. I made them all green because no one can argue against agility. No one can argue against reliability or performance or speed or safety. They're all good. But when they all put them in the same place, you're having tension. So you got to sort of figure out how your culture is going to handle that. So then you go into the process part, develop policies and governance for data and deployments. How do you get the data? Who gets to see the data? Is it what level of data it is? I've had all kinds of tier 1, tier 2, tier 3, bronze, silver, gold. I've had all kinds of versions of tiering of the data sets, and they all have different SLAs. So you need to have this discussion with data science on what kind of SLA do you need for your data? How do what guarantees can you provide? And you'd be surprised how little SLA data scientists want. All they want is all the data. So that's a different problem, but you have to have this discussion in your company. And then attach data science to your existing app and data lifecycle. That's the super important part. We talked about that. And then finally, you want a platform that actually supports you on your automation and reproducible journey. Azure Machine Learning and Azure sort of provide a lot of those tools. And I think as a forward-looking thing, I think it's really interesting to think about IT providing self-service as data science in a self-service manner. If you think about those 4 boxes, what data do you need? For training, what set of tools and what set of compute do you need? For inferencing, where do you want to deploy? And in terms of the application, you sort of have a bounding box of stuff that you want to sort of provide a data scientist. And so as you look forward, think through how you're going to operationalize all the questions that you're going to ask for this data set and the compute and everything else, make them policies, and then create a workspace just with all of those things together. And that allows you to sort of get in the way, give the data scientists what they need in terms of a free environment to work in, but they also allow it to be compliant with all your governance and policies. So we're working on this problem a lot as part of our sort of enterprise readiness vNext to sort of really think through how we build those kind of capabilities in. But we also want IT to think about how do you think about this as a self-service offering. All right, so with that, I'm done. I just wanted to sort of point out it's late in the week, so you can see me again if you want. Ask me anything. We have a great session on labeling, and then tomorrow we have David Aranchik, who's talking about how we do open source. It's a huge, deep subject for us, and we want to make sure you're open source in multiple levels. So we have those sessions as well. So with that, I'm happy to take any questions. Thank you.